Let me start by saying I'm a Booz Allen. Some time ago, I did a 2-year assignment at NSA. I took a little break, did some DARPA work, but then went back to the ODNI and worked at IARPA as a program manager for counterterrorism. So I think you heard me refer to that one of the last speakers. And because cyber is really a big data problem, I kind of moved my whole big data analytics for terrorism and moved it into the cyber realm. Eventually joined another big defense contractor and went off, started to build really like nation-state size cyber operation centers. And after that, I joined Booz Allen, and now I lead a team of about 70 engineers. We're really focused on platforms, what we call platforms, which are like mobile phones, medical devices, industrial control systems, SCADA systems, cars, tanks, vehicles, pretty much anything that has embedded systems and IT systems on them. That's my focus area for my team. So the talk that I'm going to present is really about this concept of cyber Judo. How many black belts do we have in any martial arts? 1, 2, 3, 4. Okay, so we got a few. Okay, 5. I see one up there. So I would expect that we would have a few in the audience. We typically do. And I think that those of you who have actually attained that level of performance did it through many of the mechanisms that I'm going to talk about in a moment. So I set the context. We're talking about platforms, not IT systems necessarily. And I'm also talking about a concept where we begin to take some of the things that we've done already. So you're going to hear Mike from DARPA talk about what they did in the Grand Challenge, which is in many ways a companion to what I'll talk about here. So essentially, I describe cyber Judo as being a formula, easy to follow, easy to present. But it really says that if you can use your experience, use experience-driven strategies so that you understand your adversary's weaknesses, so that you now you're kind of baiting them so that you understand what their potential failure modes are. That's good to know. Deception is a key part of every interaction. So there are nations such as China where deception is their first and foremost form of attack and strategy. So using deception to encourage adversaries to reveal their tendencies, and also so that you can conceal yours. So think about, again, on a platform, what I'm talking about is a different way to think of having embedded systems defend themselves. Because what we're talking about, we're entering into an era of resiliency. We've been under attack for a long time. And we've been defending as best we can using the boundaries, securities that we have. But in fact, we've been prohibited to some degree in terms of defending ourselves. But let me depart from this for a second and have you think about this. Today, I rode here in an Uber car. Maybe some of you did too. In the not too distant future, that car will be autonomous. And so, as I would approach this autonomous vehicle, how would I know that that car isn't going to basically hijack me and turn me into a ransomware kind of event, right? So we know ransomware in terms of theft of data and systems, but how do you know that you're going to get into that autonomous vehicle or give the authority to these vehicles like air platforms and that you're not going to be subject to some form of ransomware? Wouldn't you expect that those platforms have some form of self-defense? That's really what I'm talking about here. Because if we're going to move to autonomy, and we're going to move to resiliency, you must have the ability to protect yourself. And that platform has to be able to take care of its own problems. So internally on that platform, it has to be able to maneuver and observe the adversary to see. Now, so it's using deception to try to reveal to the attacker that they can maneuver in certain ways. And we talked earlier this morning about machine intelligence and how there's actually now some proof that if you use data and machine intelligence wisely, you can achieve some of these goals. So by maneuvering and trying to maneuver your opponent into certain aspects or parts of the platform, you can either tell that it actually is a deliberate adversary or it is not. So you may be able to maneuver it and isolate it. I'll talk in greater detail about that. And as my larger bumper sticker says, you seek to avoid conflict, you act decisively, you use the opponent's momentum, and you use it to your advantage. So attack is a strike in martial arts, which you use only decisively in the intention to win. Now, in the cyber business, we often think of attacking an adversary for the purpose of disabling a nation state, and thus attribution is an important issue. In this case, attribution is less of an issue because it's simply on the platform. It may be a piece of code, it may be some data, and so what you're really trying to do is disable that, not a nation state. And finally, as the adversary maneuvers, you want to use your counter maneuvers to get them to use their momentum to take them off the path that they intended to go. So let's dig a little deeper into this. So experience, right? You want to keep a low profile. You want to try to avoid head-to-head conflicts that you're not capable of winning. So you don't want to defensively kill things that you are not sure that they're actually an adversary. It would actually do serious harm if you had a pacemaker and it began to disable itself, right? That would be bad. So those are the kinds of things that you want to delay. You want to use deception. You want to expect that your adversary is using it as their primary form of offense. So what we see in the IT systems is that our adversaries do move very deceptively and very stealthily. And they move through points at which we should be able to see them with all the sensors and probes that we have, and yet we fail to see them. And it's because they use various forms of deception, multiple avenues of attack, so they're basically drawing our attention away, and then they're maneuvering in another space. So you want to anticipate the adversarial's movements, and you want to spring to the offensive only when compelled to do so. When you do attack, you grip your opponent, right, and you act decisively. So anyone who's got a black belt in a martial art understands that when you actually take a hold of your opponent, as much as you're trying to test their maneuvers, what you're really looking for is to take that lever point that you have on them and use it to your advantage. And thus, you use their momentum to your maximum advantage. So let's talk about some other details. So we saw a mention of a shodan. In Judo, a shodan, if you don't know, is a black belt. There can be different levels. But we all want to become one if we want our systems to be secure. And so as we look at the experience side, what does this shodan, what are the characteristics of them? And why would we want them? So shodan knows really what their vulnerabilities are. They understand their vulnerabilities, they understand their opponent, and they understand what their tendencies are. So if they've never seen this opponent before, they're going to maneuver around a little bit to see how they move their feet, how they balance, how they respond to different types of strikes and imbalanced maneuvers. So the shodan is prepared primarily through experience by practicing and testing, and thus when you become a black belt in any martial arts, it's because you've practiced vigorously, you've repeated these moves over and over again, you've worked with a variety of opponents, you've tested different approaches, you've failed often. So think of this in terms of machine intelligence, right? We have lots of experience. We know how attackers typically behave. We know the tools they use. We know the motives they have. There are a few motives that we may not anticipate, might be surprised, but with the automation that we have at our disposal, deep learning and machine intelligence now gives us the ability to be able to do that. So maybe you're actually believing what I'm saying, but let me take this a step farther. What I'm actually saying is that the machine intelligence and machine learning aspects are actually on the board. They're on the chip. And that will have some profound engineering consequences, and I'll talk about that in a moment. So here's an example, and I think that this was actually highlighted in an earlier briefing this morning, but it was about GPS and how we typically fail to key them. And so we don't key them because it's inconvenient. Our adversaries know this. The adversary uses that knowledge against us. So what if, for every mission-critical platform that we have, we design in the disparity and capacity within those systems to allocate compute resources for the self-defense of that platform? And the point of that is that we have fallen victim of our rigorous engineering processes. So most of the platforms, phones that we have are bound by size, weight, and power. And so the phones keep getting smaller, the devices get smaller. But in fact, we now are at a point where we could actually afford more power, more compute, and we could probably live with a little bigger device than we currently have, such that the device could take care of itself. So for those of you who are young engineers, you might begin to challenge the rigor that has been imposed upon you about always fitting things within the space and the power constraints that you have. You might challenge that and find out that you actually have more space than you imagine. So deception. So the key thing here is that our adversaries know what we want to do. In fact, they know more about us than we know about ourselves. And NSA has, on numerous occasions, publicly proclaimed that. And so it should be no surprise. So we need to use our own counterintelligence to reinforce what we want our adversaries to know. And that's an element of our security of our mission-critical platforms that's only partly there. But in order for that to work, it needs to actually work extraordinarily well, right? So we all know that for the things like the F-35 and the Abrams tank, the designs have been stolen, the engineering plans, they understand fully our lifecycle management process, they know fully how to get into our devices in our depots, they know how to get into our supply chain of the manufacturers of those devices. So what we need to do is look at this as a full spectrum cyber problem and address it across the full life cycle. So we need to understand that deception has to begin across the whole life cycle. So I often say, in 1981, Ford had a slogan that lasted for 17 years. Does anyone know what it is? Just shout it out. It was, quality is job one. Do you remember that? It lasted for 17 years. And that slogan began in '81 because the Japanese actually were producing better quality cars. And Ford had to convince their customers that, in fact, they took it seriously and that there would actually be evidence of that quality being baked into every aspect of the car. I would suggest to you that we have to actually change and pick up that motto, that slogan. But the slogan is security is job one. And what that should mean to us is that security has to exist in every layer of the lifecycle management process for all of these platforms, including the engineering processes and the sustainment processes. So it's no surprise. China is using us like a takeout diner, right? So they can pick away at what they want. They've got the luxury of time, and they're not the only ones. The technical vulnerabilities, they continue to persist, as I said, mostly driven by this overwhelming, compelling argument to meet size, weight, and power constraints. So communication links, as I say here, are often designed to be perfectly optimized to meet the demand, and maybe they should have a little more bandwidth allocated to self-defense. So this is our current idea of security, right? Build big walls, keep them out. You can see the fortresses have fallen. And so now, we need to know what our adversaries know about our fortresses. And what you see here is the architectures, our full lifecycle management process, and our standard operating procedures. For insiders, they would be happy to get inside our depots. They do, we know they do. And they just accidentally connect their iPhone to a piece of device because they want to recharge it. That's all they want to do, right? So at least that's what they say. So we know that that's across this entire spectrum is a vulnerability. And so this continues to reinforce this sort of deception perception, right? So there is a militarized force who's focused on penetrating our most precious platform systems. So we need to know we need to make what they know wrong. So when they steal the designs and they understand our processes, what we need to do is use deception and agility so that what they know is actually not right. And that creates uncertainty, and then it actually raises the bar for them to actually attempt to make an exploit on any of the platforms. We can do this through design, right? So we can have deception in the design itself. We can have deception in the credentials of the individuals that use it. So you can have super users with credentials on the platform that should never be used. If they ever get used, you know it's an attacker who's pivoted and used elevated credentials. Information deception. We have a lot of information flowing. We're very good at it. Why don't we fill some of that information space with bad information and filter it out when we get it on the other end? Again, deception. Checkpoint diversity. So we have execution in the code and in the hardware, so we can use diversity at the checkpoints to verify that these are, in fact, authenticated processes. So that's why I say this is a challenge to you as new engineering students, and use counterintelligence to drive this home and make it work. So maneuver is a critical part of this, as I mentioned, and I will say that we need to learn the adversaries' TTPs, their tactics, techniques, and procedures. That's how we learn. That's how we can develop the onboard machine intelligence to be able to defend ourselves within the platform. And finally, I refer to a really nice paper written by Scott Applegate back a few years. But he actually outlined a taxonomy for maneuver in the cyberspace. And so I won't go into them here, but I think you can imagine, even in the moment, what some of these mean. So exploitive maneuver, to take advantage of an enemy. Positional maneuver, by maneuvering within your own platform. Perimeter defense is a standard one we've used. And lastly, counterattack. So you can see there's a wealth of information that already exists. So this is not a new concept. But this is a house of mirrors. And this is what you want your adversary to see when they get on your platform. You don't want it to be clear to them. You want it to be uncertain to them. And you have to create uncertainty and yet have the certainty that the platform will perform its intended function as it was designed. So finally, attack. This is kind of cool because the guy's smiling. I don't know why he's smiling. He's about to get flattened. But it's a neat picture. So deception is the #1 method of attack, right? Attack does not have to be a physical confrontation. It's preferred to use deception. Maneuver is also a form of attack, as you saw a moment ago. Direct confrontation, you try to avoid as much as possible, but you try to conceal your intelligence and your counter-intel as much as you can. Use deceptive practices as often as you can. And then when necessary, you fight to win. You fight as a last resort. And because you could, in fact, do harm to your platform or the mission for which it was being used. So adversary's momentum is the last piece of the equation, but it's a force multiplier. As the adversary maneuvers and tries to counter-maneuver against us, it reveals its intentions. It gives us indicators of where it intends to go, what it intends to achieve. And momentum is an opportunity for us in terms of the form of misdirection. As they start moving themselves into some part of the platform on the processor, you can actually begin to isolate them. You might reduce their privileges. So there's a variety of things you could do. So, in summary, this is the simple equation that we've come up with to describe cyber judo. And I'll reveal to you that for those of you who are martial arts specialists, I actually used this as a deception of my own. The graphics that were in here, some of them are karate, some of them are taekwondo, and some are judo. So the point is, even in the midst of the briefing, what you saw was a degree of deception, but it looked real. And so I think my time is up in 3 seconds. So.
Last year when the Sony hack happened, everyone was saying that it was North Korea.
Yeah.
Myself and a number of my colleagues were saying it was actually China with one of their deceptive operations pretending to be North Korea and actually placing Chinese code in it to make it look like it was Chinese. What do you think about that?
actually know more than I can say. So I think that a lot of your supposition is correct. In the context of my talk, I don't know that it's important that we attribute it necessarily to the attacker. What we would have preferred to be able to do is to blunt the attack or reshape it, right? So, and I think in your earlier talk, you talked about some of those aspects of it's an uncertain game, right? You don't really know who your adversaries are, and you don't know how long they've been in the system. I would refer maybe to change the conversation to one I know less about, is the New York Times attack. And so the New York Times was penetrated by the Chinese because they were doing a special section on Chinese dissidents. And that they were approached by the Chinese to not run that story. They ran the story, and they were hacked. So, unlike the reputational attack that Sony went under. So, I know I kind of veered off on your question. So,
one of the things that you said, from what I'm understanding, are you proposing that we set up some type of honeypot for the platform itself? Because from the lessons and best practices perspective, I'm wondering how would that work? If you care to elaborate just a little bit on it. I know you have time constraints, but is that what you were saying? Some type of platform honeypot to draw them to the misinformation or disinformation?
in our preparation of this, we didn't think of it as a honeypot because we felt that the platform itself was already the honeypot. So that the fact that the adversary is attracted to it, we know that they will be attracted to it. So the issue for us was how could we tell legitimate machine instructions and activities from illegitimate ones. So we didn't actually consider a honeypot as a design alternative.
The definition of win in this environment is very difficult. Could you care to opine on how you picture that?
Yeah, that's I hadn't really thought of that question, but thank you. So I think, I go back to the martial arts metaphor. To win in that context is not necessarily to kill, right? So it is to gain control over. It is to get them into a submissive position, and maybe in some cases get them to tap out or quit, right? So I think win is really containment. It could be destruction, not necessarily, but containment and control. Great question.
Obviously, there's a bunch of different types of platforms out there and different things that are out there that are talking about deception and moving things around and hiding things in plain sight. What I also want to do is see if you can weave a couple of the last presentations with yours. So for what you're talking about, are things like automation and attribution necessary in order to be able to be deception, maneuver, understand your enemy?
Right. So, I was intrigued by many of the discussions I heard in the morning because they touched on the aspects of, economic impact of cyber attacks and the sort of the political aspects of it, as well as the technical space, right? So all of these come together in the context of an economy, which is really why we're here in New York, right? We're here because this is the center of the economic power for the United States. And many of the platforms that they rely on to conduct banking operations, whether they're ATM machines or the online systems, through our mobile phones, those, being able to defend those, many clients are customers of the commercial side are fearful that their information will be stolen, that their personal credentials will be stolen. And just like my Uber description where I said, how can I trust that I can get in the car, that it'll get me where I want to go if it's autonomous? And I think for all of us, we're a digital economy. And we will all have medical devices that are wireless. We'll have mobile devices that we carry with us. I think particularly about putting my children in an Uber car to take them to school and bring them back every day. And how could I trust it to do that? So I think based on what I heard this morning and what I described this afternoon, I think there's a synergy that it says we have to think about the problem differently. It is a big economic problem because it costs money. I have an entire another talk about how we should change the conversation about security to being one about engineering where you get security for free. It follows on that the quality is job one for Ford, right? You didn't buy your Ford vehicle and pay extra for the quality, did you? Right? You expected it to be a part of it. And so essentially it was for free because they didn't raise the price. So that's how I'm thinking of it.